Welcome to our deep dive looking at potential tipping points in the Earth's climate system. We're diving into a research paper that really gets into the weeds on this complex topic, and luckily we have an expert here to help us break it all down.
That'd be here.
So let's start with the basics. What exactly is a tipping point?
Well, a tipping point is kind of like a threshold,
Hmm.
where a small change can lead to a really dramatic shift in the state of a system, and often you can't go back.
Like a point of no return.
Yeah, exactly. Like think of a seesaw. Once it tips over, it takes a lot of effort to get it back to level. The tipping points we're talking about today are the ones that could be triggered by human actions, within this century and could have massive consequences for the next 1,000 years.
Okay, so these are things that could happen within our lifetimes and have a huge impact on future generations. The paper outlines 4 conditions that make a tipping point significant for policy decisions. Can you walk us through those?
Sure. The first one is about what they call a qualitative change. It's not just about things getting warmer or colder or whatever. It's about a fundamental shift in how the system behaves.
I see.
Imagine a forest gradually drying out. That's a quantitative change. But if it dries out so much that it catches fire and burns down, well, that's a qualitative change. It's fundamentally different.
So it's not just about the degree of change, it's about the type of change and the fact that it might be irreversible.
Exactly. The second condition is that a policy-relevant tipping element must be something we humans can actually influence.
Right.
For example, deforestation, which is driven by human activity, can really contribute to tipping points in ecosystems like the Amazon rainforest.
That makes sense. So our actions could either push these systems towards a tipping point or help prevent it. What are the other 2 conditions?
Well, the third condition is that it has to be able to be tipped within a time frame that policymakers can actually work with, so typically within this century. And the final condition is that it has to have a really substantial impact, within an ethical time frame. So basically the next millennium. It's about considering the long-term consequences of our actions for future generations.
So these tipping points have to be something that we can influence now, and they'll have a major impact on the world for a very long time. The paper mentions Arctic sea ice as the most immediate threat. Why is that?
The Arctic is warming like crazy, twice as fast as the rest of the planet. And as that sea ice melts, it exposes darker ocean water, which absorbs more heat from the sun.
Oh, I see.
So it creates this feedback loop called the ice albedo feedback,
Hmm.
where the more ice melts, the warmer the Arctic gets, and the faster the remaining ice melts.
So it's like a vicious cycle that speeds up the melting process.
Exactly. And what's really worrying is that what we're seeing now with the Arctic sea ice decline is actually worse than what the models predicted. It suggests that we might already be past a tipping point for summer ice loss.
That's a scary thought. Does this mean we'll soon see an Arctic with no ice at all?
Well, the tipping point for year-round ice loss is still uncertain, but even just losing the summer ice has massive consequences. It messes up ecosystems, impacts weather patterns, and speeds up global sea level rise. It's like we're removing a giant mirror that helps to cool the planet.
It sounds like the Arctic sea ice situation is already critical, and the consequences are far-reaching. The paper also discusses the Greenland ice sheet. How is that being impacted?
The Greenland ice sheet is facing a similar feedback loop. As warming melts the ice sheet gets lower, which exposes it to even warmer temperatures, leading to even more melting. It's like when you pour water on an ice cube. As the edges melt, more of the surface area is exposed to the water, and it melts even faster.
That's a great analogy. Are there signs that this is already happening in Greenland?
Yes, unfortunately. Observations show accelerating mass loss, thinning coastal margins, and surging glaciers all happening much faster than the models predicted. The IPCC even projects that we could see a tipping point for the Greenland ice sheet within this century.
So this is a very real concern. The West Antarctic ice sheet is another area highlighted in the paper. What makes it so vulnerable?
Well, the West Antarctic ice sheet is actually grounded below sea level, so as the ocean warms, it can undercut the ice sheet and cause huge chunks to break off and melt.
So the warming ocean is literally eating away at the base of the ice sheet. Has this happened before?
There's evidence that suggests that the West Antarctic ice sheet retreated at least once before during the Pleistocene. While the details of past retreats are uncertain, they show that the ice sheet is very vulnerable to warmer temperatures. Today, gravity measurements show that there's ongoing mass loss, and observations show that the glaciers that drain into the Amundsen Sea are losing more ice than they're gaining, and this is directly contributing to global sea level rise. These tipping points really highlight just how interconnected all of the Earth's systems are and how our actions can have these wide-ranging impacts. It's a pretty stark reminder that our choices today can have huge consequences for the planet's future.
The paper goes into a lot of detail about what actually defines a tipping element and its tipping point. Can you explain that a bit more?
Sure, they define a tipping element as a large-scale component of the Earth's system that can shift into a completely different state because of even small changes. The tipping point is that critical threshold where this shift happens. It's kind of like a domino. Once it's pushed past a certain point, it sets off a chain reaction that you can't easily reverse.
So these tipping points aren't just isolated events. They can have a ripple effect across the entire system. The paper specifically focuses on tipping elements that are relevant to human actions and policy decisions. Why is that distinction important?
Well, they argue that policy-relevant tipping elements are the ones that we can actually influence with decisions made within a political time frame, so basically within a century. They also say that these tipping elements should have big consequences within an ethical time frame, so extending out to the next millennium.
So it's about focusing on the tipping points that we can realistically do something about within our lifetimes and that will have the biggest impact on future generations. The paper acknowledges that many of the systems they talk about don't actually have definitively established tipping points. Why focus on them then?
Even though we don't know the exact location of some tipping points, it's still crucial to understand these potential tipping points, especially with the growing need to set those binding temperature targets. We can't wait until we're absolutely sure, because by then it might be too late to act.
It's like a better safe than sorry kind of approach,
Yeah.
especially with such high stakes. The paper emphasizes that it's not just about climate variables, but also non-climatic factors. Can you give some examples of how those come into play?
Sure. Human activities like deforestation and pollution can have a huge impact on ecosystems and contribute to tipping points. Political decisions and economic systems also play a role in shaping how we respond to climate change and whether we can mitigate these risks.
So it's not just about the science of climate change. It's about understanding the human element and how our choices impact these complex systems. The paper also talks about the different time scales over which tipping points can happen. Can you break those down?
Tipping points can unfold over different periods of time, ranging from really rapid and abrupt shifts to gradual changes that happen over centuries or even millennia. Rapid tipping points like the potential collapse of an ice sheet could happen within our lifetime, while slower tipping points like the acidification of the ocean might take centuries to fully play out.
So some of these tipping points could really catch us off guard, while others are more like slow-motion train wrecks that we can see coming but still have trouble avoiding. The paper focuses on 9 potential tipping elements in the climate system. We've already talked about Arctic sea ice, the Greenland ice sheet, and the West Antarctic ice sheet. What are some of the others they highlight?
They talk about the Atlantic meridional overturning circulation, which is a system of ocean currents that's super important for regulating global heat distribution. If this circulation slowed down or collapsed, it could dramatically change weather patterns and regional climates.
So it's kind of like messing with the planet's central heating system. What other tipping points did they look at?
They also discuss the El Niño Southern Oscillation, which is a climate pattern that affects weather events around the world. Changes in this pattern could lead to more extreme El Niño and La Niña events, which can cause floods, droughts, and heat waves.
It sounds like that could have a major impact on things like global food security and water resources.
Absolutely. They also look into tipping points in the Indian summer monsoon, the Sahara-Sahel and West African monsoon, the Amazon rainforest, and the boreal forest. These systems are vital for regulating regional climates, supporting biodiversity, and storing carbon. Tipping points in these systems could have huge consequences for both people and ecosystems.
It really emphasizes how interconnected these systems are and how disruptions in one area can affect the entire planet. The researchers use something called expert elicitation to assess the sensitivity of each tipping point to global warming. Can you explain what that is and what they found?
Expert elicitation is basically a structured way to gather expert opinions on a specific topic. In this case, they asked experts to evaluate how sensitive each tipping point is to changes in global temperature and how much uncertainty there is around those evaluations. This helped them categorize the tipping points into different threat levels based on their potential impact and how confident we are in the predictions.
So it's like asking the world's top experts to tell us which tipping points they're most worried about and how sure we can be about what we know. What did they find out about the different tipping points?
They found that the Greenland ice sheet and Arctic sea ice are super sensitive to warming, which means that even small temperature increases could trigger really big changes. They also have the least uncertainty, which means that scientists are fairly confident in their predictions about these tipping points. These were labeled as the most immediate threats.
So those are the tipping points that we need to be most worried about right now. What about the others?
The West Antarctic ice sheet, the boreal forest, the Amazon rainforest, the El Niño Southern Oscillation, and the West African monsoon were categorized as having intermediate sensitivity to warming. Their potential impacts are significant, but there's more uncertainty about how they'll behave. The Atlantic thermohaline circulation, which has low sensitivity to warming and some uncertainty, was categorized as a less immediate threat. But its long-term fate under significant warming is still a concern.
So it's a mixed bag of threats, some more immediate and certain than others, but the fact that we're even discussing potential tipping points in these essential Earth systems is pretty alarming. The paper highlights the need for early warning systems to help us anticipate these tipping points. Can you elaborate on what those systems might look like and how they could be helpful?
Early warning systems for tipping points would involve monitoring key indicators that can tell us about the stability of these systems. For example, by looking at real-time data on things like ocean temperature salinity and current patterns, we could potentially see early warning signs of a potential slowdown or collapse of the Atlantic thermohaline circulation. Likewise, keeping track of deforestation rates, rainfall patterns, and vegetation changes could give us early warnings of tipping points in the Amazon rainforest.
So it's kind of like having a network of sensors that are always monitoring the planet and looking for signs of trouble. If we do detect those early warning signs, what can we actually do about it? Is there any way to prevent these tipping points from happening?
Early detection is key because it gives us a chance to act. If we know that a system is approaching a tipping point, we can try to put mitigation strategies in place to avoid the worst-case scenario. For example, if we detect signs that the Atlantic thermohaline circulation is becoming unstable, we might need to ramp up our efforts to reduce greenhouse gas emissions or develop strategies to adapt to the changes in regional climates.
So these early warning systems aren't just about predicting doom and gloom. They're about giving us the power to take action and potentially change the course of events. The paper talks about the difficulties in developing effective early warning systems for these really complex systems. What are some of the biggest obstacles?
One of the biggest hurdles is the sheer complexity of these systems and all the different factors that influence how they behave. We need to improve our understanding of the basic processes and develop more advanced models that can accurately simulate these systems and predict how they'll react to different stresses.
So we need to get better at the science and modeling aspects. What other challenges are there?
Another challenge is the need for more comprehensive and reliable observation networks. We need more sensors and more places to gather data on key indicators, and we need to make sure that this data is easily accessible and shared within the scientific community. We also need to invest in long-term monitoring programs to keep track of changes over time and spot trends that might indicate an approaching tipping point.
That sounds like a massive undertaking that would require a lot of investment in research technology and international collaboration.
It's a big challenge for sure, but it's one we have to tackle if we want to avoid the worst consequences of these tipping points. The future of our planet really depends on our ability to understand and respond to these threats.
It's definitely a call to action for scientists, policymakers, and even individuals to come together and find solutions. We need to invest in the research, develop the technology, and put the policies in place to build a more sustainable and resilient future.
It's a race against time, but there's still hope. By recognizing the possibility of these tipping points and being proactive in mitigating the risks, we can try to ensure a safer and healthier planet for generations to come.
It's really a wake-up call, isn't it? These potential tipping points in Earth's climate system paint a pretty stark picture of the challenges ahead.
It really does make you think.
It's like we need to hit the reset button on how we think about climate change. It's not just this gradual, predictable thing anymore. We have to be prepared for these sudden, irreversible shifts that could completely change the game for human societies and ecosystems everywhere.
Absolutely. It's not just about understanding the science, it's about using that knowledge to make better decisions.
Right. We have to translate what we know about these tipping points into real, concrete action.
Exactly. It's not enough to just say, oh yeah, climate change is happening. We have to actually do something about it.
So what are the key takeaways here? What do we really need to remember about these tipping points?
Well, for me, one of the biggest takeaways is that everything is connected. What we do in one place can have a ripple effect across the entire planet. Our actions have the power to trigger some really major and long-lasting changes in the Earth's climate and ecosystems.
It makes you realize that we can't just sit back and wait for things to get better on their own. We have to be proactive,
Exactly. We need to take a precautionary approach. Act now to reduce the risks rather than waiting until it's too late.
So this research is basically a giant flashing red light saying, hey, pay attention to climate change, do something about it.
Pretty much. It's a global issue that requires a global solution.
It's a call to action. We have to work together, reduce greenhouse gas emissions transition to sustainable energy sources, and adapt to the changes that are already happening.
Yeah, we need to shift our mindset. This isn't just about protecting the environment anymore. This is about protecting our communities and our future.
It's been a fascinating deep dive, and it's definitely given us a lot to think about. Thanks for breaking it all down for us.
It's been a pleasure.
And thanks to everyone for listening to The Deep Dive. We'll see you next time.